In addition to terrestrial biomes, of course, there are aquatic biomes on Earth. Aquatic biomes include marine water, so ocean, and also freshwater. And we're somewhat biased in looking at terrestrial biomes because we tend to live in terrestrial biomes, but aquatic biomes do cover 3/4 of the Earth's surface, and most of that is salty water, so oceans, reefs, and estuaries. And then, of course, there are some that we probably experience more on a day-to-day level, which would be freshwater systems, which would include rivers, lakes, bogs, and other wetlands. So we talked about how precipitation and temperature dominate terrestrial biomes. With aquatic biomes, you're looking more at factors of temperature again, but then also light and nutrients that moderate these aquatic biomes. And this can lead to layers in the aquatic system because, as you can imagine, light doesn't penetrate very far through the water column. And so there's different ecosystems and different biomes at the top of a water column than there would be down deep where the light cannot penetrate. And that's similarly true for nutrients. The nutrient distribution is not even across a body of water. Aquatic biomes, just like terrestrial biomes, are subject to daily changes, and for aquatic biomes, especially if we're talking about, well, when we're talking about ocean systems, then that would include tidal changes, which is somewhat affected by the sun, but more affected by the moon. And then seasonal changes, just like terrestrial biomes. Aquatic biomes experience seasonal changes. When we're talking about freshwater systems, like lakes and ponds, they might freeze over in the winter. And then there's some aquatic biomes that are not full of water year-round. So there's some wetlands that are full of water in the late winter and spring as snow melt occurs and as there's more rainfall, but then they do dry out in the summer. And so the organisms that live in those biomes must adapt to the influx and disappearance of water from their system. There's 4 major zones in the ocean biomes. These zones include the intertidal zone, so that's the zone we experience most often as people. This would be the shoreline, and then areas that are sometimes submerged and sometimes not submerged depending on tides. And there's a lot of fun critters that live here, algae, but also crabs, sea stars, snails, clams, crustaceans of many types, crabs, and shorebirds. So shorebirds, even though they live on land, they also live in this intertidal zone, floating out on the water, some of them. The next zone, if you go down in depth in the ocean, would be the pelagic zone. This is considered to be part of the open ocean, but it's the top region of the open ocean. So again, that's the part that we would interact with most as people. And in this zone, there's a lot of seaweed floating. There's larger fishes, and there's mammals like whales and dolphins that hang out and scavenge for food in this area. If you go down a little further from the pelagic zone, but out into the open ocean, then that's called the benthic zone. In the benthic zone, there is some light that can get through, but not very much. So it's not as light, and it also is colder because in this area, temperature is decreasing as you go deeper. There are still lots of nutrients in the benthic zone, and so it is home to lots of fishes. So seaweed and many types of fishes, worms, sea stars, and anemones, sponges, and then of course bacteria and fungi, which are everywhere on Earth. And then finally, if you go very, very deep into the ocean, you're in the abyssal zone. This is the very deep ocean that we are not able to explore very well. This water is very cold, and it's under there's very high pressure because of the weight of the water above you in the water column. And there's oxygen, but not very many nutrients. Another thing that we find down in the abyssal zone are areas of hydrothermal vents, and that's pictured here in the slide. hydrothermal vents are very interesting because they supply nutrients that aren't present in other parts of the ocean. So you get things like hydrogen sulfide loving bacteria that grow up here on the hydrothermal vents. And you get odd animals that like this, that have adapted to this biome and ecosystem. So there's a lot of invertebrates down there and some interesting fishes. When we talk about freshwater biomes, that's a huge range because some freshwater biomes are very small, so you can think of a very small lake in the middle of a subdivision all the way up to the Great Lakes, very large, which would be a very large biome. There's a wide range of conditions for freshwater biomes depending on what latitude you're at. Are you in the Arctic? Are you in the tropics? What kind of temperature ranges does that biome experience? And then we talked about how wetlands can dry up, and so life that lives in smaller wetland habitats, they must be able to adapt quickly, or they must be adapted to a variety of conditions because that habitat could dry up, or it can get hot or cold very quickly if it's a very shallow lake. And so organisms must learn to survive in a lot of changing conditions, as opposed to the ocean biome in which the conditions stay relatively static over time.